Okay, again, so the benzene ring will not easily undergo addition, right? So even though it looks like there's double bonds on benzene, benzene does not have double bonds. It has something in between a double and a single bond. So it will not undergo addition reactions. It will undergo substitution reactions. We are substituting one of the hydrogens for one of the bromines. Okay, so it's one of the bromines for one of the hydrogens. And the name of this is bromobenzene. Okay, so if you start then with bromobenzene and you do more substitution reactions, there are three possibilities. All right, so there are three possibilities, and I need a little more room for my bigger writing. Right, so if I'm going to add one more bromine to this bromobenzene, I could add it in the ortho, the meta, or the para position. Right, it could be 1, 2, 1, 3, or 1, 4. Right, if we're going to add one more bromine, I could then have and again, I'm substituting, right? And you can do that substitution on your model if you would like to continue. And this is going to be an or, right? Or. We're going to have the 1,2 substitution, so 1,2 dibromobenzene. We're going to have 1,3 dibromobenzene. And I need a little more room. Or we can have the 1,4 dibromobenzene. Right, so those are three possible outcomes by reacting bromobenzene with bromine. And again, the key for any reactions with benzenes, right, so aromatics are benzenes, is that they will not undergo addition reactions. And really, it's because this ring is too stable for an addition reaction. It's not really a double bond. They look like double bonds, but they're actually sort of in between a single and a double bond. But they will undergo substitution reactions. Okay, another type of substitution reaction with benzene is nitration, right? So we're going to add, in this case, we're adding NO2, right? So we're reacting it with NO3, but we're adding just an NO2. So what you get here you actually get water out of this right here. And anytime you're pulling water out of things, sulfuric acid makes things go better. So this becomes nitrobenzene. Let's put all right, and then so you will be responsible for knowing these reactions, but not their names. Right, so you would be responsible for knowing if I react benzene with HNO3, it makes benzene with an NO2. It's called nitrobenzene, but I won't ask you. I'll ask you for that reaction, but not name the compound it makes. Okay. Alkylation belongs. Sorry, I'm just gonna belongs down here. Okay, so that's another reaction. You have substitution with halogens. We have substitution with nitric acid, right, with HNO3. And then the other type of substitution we have, and these are tricky. It's called an alkylation. All right, so if you want to get this alkyl group attached to the benzene ring, it has to be attached to this chlorine that actually makes it easy to do the substitution part. Right? So alkanes, as we know, don't react easily. Right? They will react with chlorines, with UV light. Alkanes will undergo combustion. An alkane on its own won't react with this benzene ring. But if you would attach a chlorine to it, it will react. And so you can get it to do this. Right? So an alkyl halide can do something called alkylation. This is an alkyl group. We can add it to the benzene ring if it reacts with an alkyl halide. So the reaction works like this. The substitution is, there's H's on all of these, but I'm just going to include that H right there. The substitution is this H is substituting for this alkyl group. Okay, so I've substituted one of the H's, and I'll just draw it out here. highlight what's happening. This hydrogen is being substituted out by this alkyl group. And if you find this a difficult concept, this is probably one of the trickiest ones to think about. Okay, so the H is being substituted by this 3-carbon group right here. So I'm adding a propyl group, right? Where the H is substituting on here, and I'm substituting them. Almost like a single displacement reaction if you're thinking of your grade 10. All right, I'm displacing the hydrogen with an alkyl group. And I can only do that with alkyl halides, right? You need this chlorine, which, you know, is quite electronegative and will easily take this hydrogen with it, right? That won't happen if you just had propane, right? You need this chlorine on here for this reaction to happen. Okay, so that's alkylation. Right, I'm adding an alkyl group.